your alkanes, okay, they are no non-polar in nature. As they are non-polar in nature, so they are soluble in non-polar solvent like your benzene, carbon tetrachloride, carbon disulfide. Okay, these are non-polar solvent. Acetone, these are non-polar solvent. So your alkanes will be soluble in non-polar solvent, or you can call it as organic solvent. Okay. Now, related to water, okay, it is insoluble in water. So this is the second physical properties of alkane. The next one is the density. Okay, so here if you look at the density of your alkane, okay, so here uh, the vapor density. Okay, now in your textbook they have given you the vapor density of methane and ethane. Okay, when we were doing with the stoichiometry, when we were doing with the empirical formula, at that time we have learned one formula that is about vapor density. Okay, kindly mute yourself, dear. So here we have learned about the vapor density. So the formula of vapor density is equal to 2 into uh, here, sorry, the formula of molecular mass. Okay, to find out the formula of molecular mass, it is 2 into vapor density. That is the formula that we have seen. So here the molecular formula is 2 into vapor density. Okay, this formula we have seen when we were doing with the empirical formula. At that time, the vapor density, it is related to the relative with hydrogen gas. So in that way, 2 is there. Okay, and you know the vapor density of methane is 8, and the vapor density of ethane is 15, which is mentioned in your textbook. The next one is about the boiling point. Okay, so here the boiling point of you can see here, as there is increase in the carbon chain. Okay, the boiling point it increases. Okay, and if there is any branch in the alkanes, okay, at that time decreases with increase in the number of branches. So this is related to the physical properties of the alkane. The next one, that is the chemical property. Now let us see the first chemical property, that is about combustion. As you know about the as you know about the combustion. Okay, now what do you mean by the term combustion? Okay, anything that is being heated in presence of oxygen is called as combustion. So here there are two things that you need to know about combustion, that is complete combustion and incomplete combustion. So when complete combustion is happening, when it is due to the presence of uh, excess amount of air or excess amount of oxygen is present. At that time complete combustion takes place. So methane, it will be reacting with oxygen to form carbon dioxide and water, and it is highly exothermic reaction. Okay, but when your alkane is supplied with insufficient amount of oxygen or insufficient amount of air, at that time it will result into the formation of carbon monoxide and water. Okay, and when there is a limited amount of oxygen, okay, at that time it will result into the formation of black carbon Okay, so these are the reactions that is related to your combustion. I want everyone to write down this reaction in your notebook. So write down the topic, that is chemical property, and the first is combustion. Write down these reaction. Okay, the one that I'm putting a tick.
Ma'am, can you just remove him?
Who is that, dear? I'm not able
Harit,
to.
Harit Dixit.
Oh, he left already.
Okay, so others, please write down these reaction in your notebook related to the combustion. Okay, the first one, that is CH4 plus 2 O2 gives CO2 plus 2 H2O, and it is highly exothermic reaction. You can see the amount of heat that is being given out, that is minus 890.4 kilojoules. Yes, Vashish.
Ma'am, actually I forgot the page number. Can you just tell the page number?
The page number here, it is page number 230. 230. Open your
Okay,
page number 230. It is there
okay,
in
ma'am.
your textbook.
Thank you, ma'am.
So, and the next one, please note down this two reactions for incomplete combustion. Now, this is happening in,
Hardik.
it is related to the limited amount of oxygen. Okay, so incomplete combustion is happening. Insufficient amount, this is related to insufficient amount. Okay, here, please mention about insufficient amount. So here it is insufficient amount of oxygen. Okay, I'm not able to use the pen properly. Okay, here you write it for insufficient amount, and here you write it for limited. Okay, very limited amount of oxygen. Very limited amount of oxygen. These two reactions, please note down in your notebook.
Ma'am,
Yes,
what
dear.
what can be the heading?
The heading chemical property. Write down the heading as chemical property combustion, dear.
Okay, thank you.
Okay, this will be for complete. This is for complete combustion. This will be for complete combustion. This is for complete combustion. And these two reactions are for incomplete combustion. Okay, now these two reactions are for incomplete combustion. One is with insufficient amount of oxygen, and one is with very limited amount of
Hello.
oxygen.
Hello. Hello.
With insufficient amount of oxygen. I hope so everyone has noted it. Can I move to the next slide?
No, ma'am. One No, second, ma'am. ma'am. Please. 1 second.
Yes, yes. Once you have finished, please inform me.
Done, ma'am.
Okay. What about others? Shall I go
Ma'am,
to the
last reaction.
no problem.
Ma'am, what have you written after that? Very
Very limited amount here. Very limited. I'm not able to use the pen properly.
okay. Done, ma'am.
Okay. So moving to the next slide, that is about halogenation reaction. So write down the next one is halogenation.
Ma'am, what
Halo-
do you write? Ma'am.
So here,
Ma'am.
about the halogenation reaction. Did we do halogenation reaction in our class? Have we done with the halogenation reaction?
Yes,
Okay.
ma'am.
So here, just a quick recap about halogenation reaction. It is the substitution reaction that is taking place here. So as you know, what do you mean by substitution reaction here? Here you can see, look at the example of methane here. Okay, so in methane, it is having four hydrogens. Okay, now all these four hydrogens are being replaced by halogens. Okay, now what type of halogens can you use here? Okay, you can use chlorine and bromine. Okay, it is commonly used for halogenation reaction. While your fluorine is highly reactive, so it will not give you a quick result. Okay, it will happen very quickly and the result will not be that clear. While iodine, it is very slow. Okay, so for doing your halogenation reaction, we would prefer to use chlorine and bromine. So as you can see here, when methane is reacting with chlorine, and here the condition is very important. The condition is sunlight. It is photochemical reaction that is taking place. Okay, so in presence of diffused sunlight, this reaction will take place. Okay, it will not happen in direct sunlight. It will lead into explosion. So we need diffused sunlight for doing this reaction. So when methane is reacting with chlorine, it will result into the formation of methyl chloride and hydrogen chloride. Okay. Again, this methyl chloride, when it reacts with the next molecule of chlorine, it will form methylene chloride. Okay. Now here, what is more important? Okay. Now normally, how do they ask this question in your paper is with the IUPAC name. You have to give the IUPAC name. Here I have given the tribal name for all these reactions, but in your paper they will be asking it with the help of IUPAC name. You have to write the reaction, or you have to write the name of the compound. So as um, for the first reaction, if you see, if it is CH3Cl, so what will be the IUPAC name? The IUPAC name will be chloromethane. Okay, that will be the IUPAC name. Now, when I am taking this methyl chloride or yes, dear, or
Ma'am, we are done with this.
we have done with this. Okay, no, just I wanted to explain so that I can move ahead. Okay, so this chloromethane, when it reacts with chlorine gas, it will result into the formation of dichloromethane. Then this dichloromethane, when it reacts with the next molecule of chlorine, okay, here the tribal name is given as chloroform. And what will be the IUPAC name? The IUPAC name will be trichloromethane. And this trichloromethane, when it reacts with again with chlorine, okay, here the tribal name given is carbon tetrachloride, while the IUPAC name will be tetrachloromethane. Okay, the same thing you have to do it with. The same thing you have to do it with ethane also. So here, as four hydrogens were there, so this reaction happened in fourth step. Okay, and if you are using, okay, ethane, okay, as it is having how many hydrogens it is having? It is having six hydrogens. So the number of step will be six. Step will be there for the reaction of ethane with chlorine. So in this way, we have finished with the chemical properties of ethane and methane. Okay, the uses of ethane and methane is there in your textbook. Okay, I want you all to go through the uses of ethane and methane. In your question paper, they can ask about any one uses related to ethane and methane. Basically, most of the time, the question is related to halogenation and combustion. Now, let us go to the next one. The next,
Hello, Logan Paulers. Hey,
the,
Logan Paulers.
the next compound is alkenes. Okay, so the another name of alkene is called as olefin. Okay, now here why it is called as olefin? Now here, what is your alkene? Alkene is an unsaturated hydrocarbon. What do you mean by unsaturated hydrocarbon? Okay, unsaturated hydrocarbons are classified into alkenes and alkynes. Okay, alkenes are carbon-carbon double bond. Okay, so when carbon-carbon double bond is there, okay, so what is that bond called as? It is called as olefin bonds. Okay, so because of this olefin bonds, okay, carbon carbon double bond, okay, so that is why your alkene is also known as olefins. So here, double bond means one of the bond is sigma bond, okay, and the other one is your pi bond. Okay, here the pi bond can easily break, while the sigma bond, it is very difficult to break the sigma bond. Okay, now if you take your alkanes, alkanes are having single bond, so single bond means they are sigma bond. Okay, while your alkene is having double bond means one of the bond is sigma bond while the other one is pi bond,
One.
and pi bond can easily break. Yes, dear. Someone want. Okay. Now the next one, as I've told you, alkenes are more reactive than alkanes due to the presence of double bond. Okay, and here, okay, how can you make these alkanes? Okay, these alkanes are made by the cracking of alkanes. Okay, and from where you are getting these alkanes? You are getting these alkanes from crude oil. Now let us go to the next one, that is the preparation of alkenes. Now here, the preparation of alkene, the first method for the preparation of alkene, you can see that is dehydration of alcohol. Now, already in your lower class, you have learned of two important terminologies, that is drying agent and dehydrating agent. Okay. Now, in your lower class, you have studied about the reagents that are being used for the drying agent, like your calcium oxide is used. P2O5 is a drying agent. Okay, so there is a difference between a drying agent and dehydrating agent. Okay, now you're concentrated. Okay, now here, when most of the time in your paper they ask about dehydrating agent, that is, who is the dehydrating agent for converting your ethanol to ethene. So the dehydrating agent is concentrated sulfuric acid, or it is Al2O3. Okay. Now here, these are the two important that has been mentioned in your textbook, two important dehydrating agent, that is concentrated sulfuric acid, and this reaction with concentrated sulfuric acid, the reaction happens at 170 degrees C. The temperature is also very, very important. Uh, um, uh, I want you to note down this, okay, in your notebook. Method of preparation of alkene. The first method of preparation of alkene is dehydration of alcohol. So from dehydration, you come to know that it is removal of water. Okay, and who helps to remove the water? Dehydrating agent helps to remove the water. Here, two dehydrating agents are being mentioned. The first one is concentrated sulfuric acid at 170 degrees C, and the second dehydrating agent is Al2O3, that is alumina, at 350 degrees C. The temperature is very, very important. You have to write down the temperature also. Now, so here, if you look at the reaction, okay, so ethyl alcohol, when it is doing the reaction with concentrated sulfuric acid, it is doing the reaction with concentrated sulfuric acid, it will result into the formation of ethene, and water is being removed. Now here, I'll just change my screen. Okay, I'll use the next screen so that I can explain this reaction to you. Just give me a minute. Now, to understand your dehydration reaction, okay, I'll just write down this reaction here. See, this is how you write your, okay, now, this is CH3, CH2OH. It is mentioned in this way. I'm just writing the structural formula of it, okay. Instead of CH3, I'm writing here CH2 and one of the hydrogen, I'm putting it here. The
Excuse me, ma'am.
another one, yes, dear.
Ma'am,
I'm not
ma'am,
able to see
ma'am,
the.
ma'am, what is
Okay,
your diet? Ma'am.
okay, wait, I'll just share it again.
Sigma bot.
Just check, is it visible now? Is it visible?
Yes, ma'am.
Okay, good. So here I have written, okay, now what is this? This is your ethanol. Okay, I'm writing ethanol in this manner. Okay, CH, okay, here I have written as CH3. So here I'm writing it in a structural way so that the concept will be more clear for you. Okay, I'm writing the structure of ethanol in this manner. So one of the hydrogen I have removed here, and here you can see OH. Okay, so what is happening here? When you are taking concentrated sulfuric acid, okay, now here very important, if you just write sulfuric acid, you will get 0. Okay, here sulfuric acid can be in the diluted form, it can be in the concentrated form. Okay, when you take dilute sulfuric acid, nothing happens. Okay, here what type of sulfuric acid? It should be concentrated sulfuric acid at 170 degrees C. This dehydrating agent you can use, or you can use Al2O3 at 350 degree C. Okay, so what is happening? These dehydrating agent will remove the water molecule from here. You can see how the water molecule is being removed. Okay, one hydrogen from the, this is the first carbon, this is the second carbon. Okay, so from second carbon one hydrogen, and from the first carbon OH. Okay, it is removed. Okay, that means water is being removed. Okay, now what is left? Okay, now when there is a breaking of bond that is taking place between carbon and hydrogen, okay, this carbon is having one electron. Here also breaking of bond is happening between carbon and oxygen. This carbon is also having one electron. So these electrons will combine to form CH2 double bond CH2. Okay, so in this way, your ethanol or ethyl
Six,
alcohol will
seven.
ethyl alcohol will change into ethene. I hope so. The reaction is clear to everyone. Is the reaction clear?
Yes.
Okay. Now here, the next important thing. Okay, now here, how will you write this? Okay, everyone has written this reaction in your notebook. Write this reaction in your notebook.
Ma'am,
And yes,
I
dear.
had a doubt.
Yes.
Could you explain again why we took concentrated H2SO4 instead of dilute?
Okay. Here, concentrated H2SO4 is a dehydrating agent. Okay, your dilute H2SO4 will not have the ability of removing the water from your ethanol. Okay, only concentrated sulfuric acid, and that too at this temperature, that is at 170 degrees C. If you lower the temperature, the reaction will change. Okay, the here it is a temperature specific reaction. So the reaction should happen at 170 degrees C, then only it will result into the formation of ethene. If you change the temperature, the reaction will completely change. So the temperature plays a very important role. So as I've told you, only your concentrated sulfuric acid is a dehydrating
Ma'am,
agent.
ma'am, reveal exam score. Yeah.
Okay, so this is related to your I hope so. Is it clear? Is it clear, the person who has
Yes,
asked?
ma'am.
Yeah.
Yes.
Now the next, have you written this reaction? Please mention.
Yes,
Okay,
ma'am.
so the reactant, okay, the reactant is, write down, reactant is ethyl alcohol, or you can write ethanol. The IUPAC name as well as the tribal name, right? Both the names, because in our paper we don't know by which name they will be asking you the reaction. So you should know both the names. Okay. The next one, the product. The product formed is ethene. The next one, here we need reagent. Okay.
Rolando, Rolando, Rolando.
I hope so. You have written this reaction, just erasing it. Okay, so that I can write it here clearly. Okay, so as I've told you, we have written the reactant, that is ethanol or ethyl alcohol. Ethyl alcohol. The next one is the product. The product is ethene. The next one is byproduct, is water. Byproduct is water. Now here the reagent is concentrated sulfuric acid at 170 degrees C, or Al2O3. Okay, what is the name of this Al2O3? It is called as alumina. Okay, at 350 degree C. The next one, okay, collection. Okay, now how are you collecting the gas? Okay, the gas is been again collected by downward displacement of water. I hope so everyone is writing this in your notebook. Downward displacement of water. Downward displacement of water. Okay. Now here purification. This is one more thing that you need to add here. That is purification. Okay. Now sometimes along with this ethene gas, there is a possibility of some other gas getting formed. Okay. That is either carbon dioxide gas is formed or sulfur dioxide gas. There is the possibility of these impurities present in ethene. So to remove these impurities, okay, when the reaction happens, okay, when the reaction happens, when ethene gas is being formed, this ethene gas is being purified. It has been passed through NaOH solution. Ethene, write down here. Ethene gas is passed
Yes, yes, it's below.
through NaOH solution. Okay, so what this NaOH solution will do, it will be absorbing the impurities, that is your carbon dioxide or sulfur dioxide, these two gases, it will be absorbing, and it will be allowing only the ethene molecules, the ethene gas to be collected in your by the method of downward displacement of water. Okay, I hope so everyone has written these pointers in your notebook along with the reaction. Can I erase it?
One second, ma'am.
Yeah. If you're finished, just tell me so that I can move to the next preparation.
Ma'am,
Yes, dear.
ma'am, do we need to write the impurities absorbed?
Yes, dear. You have to mention because these are some of the small pointers which can be asked for your MCQs. Section A.
Okay.
Diyor Bezgut kunu. Diyor Bezgut kunu. Diyor Bezgut kunu.
If you're finished, just tell me so that I can move to the next preparation method.
Ma'am, can you just tell what were the impurities?
Carbon dioxide and sulfur dioxide here.
Okay.
Yeah, because I have told na, if complete combustion is happening, okay, where even in your ethanol, when there is supply of, okay, now inside the round bottom flask, okay, if you see the, I will show you the image, okay, I have shown you earlier, round bottom flask has been taken and that some amount of oxygen will be present. Okay, so this oxygen might react with ethanol and there is a
We on
possibility
the
of
island. We on
completion.
the island. We on the island. Epstein's island. We on the island. We on the island. We on.
Okay, so this okay, so there is a possibility of ethanol getting completely combust, okay, to form carbon dioxide. So in that way, formation of carbon dioxide can also happen, and as you are using concentrated sulfuric acid, so there can be a possibility of the sulfuric acid getting decomposed to form sulfur dioxide. So, along with ethene gas, there can be a possibility of formation of carbon dioxide and formation of sulfur dioxide. We don't want these gases, so these two gases are being removed with the help of NaOH solution. Is it done?
Yes, ma'am.
Okay. We are having only a minute left. Okay. The next one, that is dehydrohalogenation reaction. We will do it in the next class. Very important reaction it is, because there are certain important pointers that you need to know about it, about why you're using alcoholic KOH. Okay, if you use aqueous KOH at that time, how the reaction changes. Okay, so all these are important pointers. I will not explain to you now. Okay, in the next class we will do it. Okay, so I hope so. Till now, whatever we have done, is it clear to everyone? Is it clear? Any doubt in these? Okay, we have done with two things. That is the chemical properties of alkanes we have done, and we have done with the preparation of alkenes. I hope so. These two pointers are clear to everyone. Okay, so I shall end the meeting. Thank you, everyone.
Thank you, ma'am.
Thank you.
Underline this. Thank you, ma'am.
Thank you, ma'am.